Who is Heinrich Hertz? If you guessed that he was the founder of the popular American car rental company with a similar name, you're not alone. But Heinrich Hertz wasn't a car rental entrepreneur. Instead, he was a German scientist who performed experiments with electricity. When electricity was still a fancy new thing that scientists had a lot to learn about. In 1888, when Hertz was 30, he made an electric spark jump from one terminal to another and noticed a second spark at the same time between two terminals a couple yards away. Exciting stuff, I know, but this was 1888, and what Hertz noticed was a different kind of electromagnetic wave that eventually came to be known as Hertzian waves. A few years later, in 1896, a young Italian scientist named Guglielmo Marconi built on Hertz's discovery. Marconi created the first radio transmitter, sending radio signals for a mile. A mile! Hertzian waves are now called radio waves and are used every day from listening to the radio to watching TV. We are surrounded by waves we can see and hear, from ocean waves to sound waves. A wave shows the transfer of energy from the wind that starts an ocean wave to the sound that moves through the air to your eardrum. Waves that pass through a physical object or medium are called mechanical waves. Unlike mechanical waves, electromagnetic waves do not need a medium to travel or propagate, though. Electric and magnetic fields both produce vibrations, and together, the two types of energy create electromagnetic waves. Waves take different shapes, but electromagnetic waves all have a snake-like shape, which makes them transverse waves. Transverse waves are measured by their height, or amplitude, and by their wavelength, or the distance between the highest point of one wave, the crest, to the crest of the next wave. The lowest point of a wave is called a trough. Trough to trough can be measured too. When analyzing an electromagnetic wave, both the amplitude and distance between waves is measured. One whole wave from crest to crest or trough to trough is called a cycle. The number of cycles that occur per second is the wave's frequency. In honor of Heinrich Hertz, we measure frequency in hertz, or Hz. Electromagnetic waves are ordered on the electromagnetic spectrum by frequency. They range from radio waves with fewer cycles per second to the extraordinarily fast and harmful high frequency of gamma rays. Radio waves have the lowest frequency of the 7 bands of waves on the electromagnetic spectrum, which also means they have the least amount of energy. Radio waves have wavelengths measuring from miles to the length of a football, or around 11 inches. It is common to talk about the frequency of radio waves or the number of waves per second. When tuning into a radio station, a person is listening to a specific frequency of radio waves. AM stations are numbered from 520 to 1610, with each number representing the frequency of the station at thousands of hertz per second, or kilohertz, abbreviated KHZ. FM station frequencies range from 87.0 to 107.9 million hertz per second, called megahertz, or MHz. Sound is converted into electromagnetic waves and sent through radio dishes. A radio then receives these radio waves and changes them back into sound waves. Next on the spectrum are microwaves, a type of radio wave that are less than 11.8 inches long. The microwaves people use to heat food has waves measuring about 5 inches. Microwaves aren't just for heating leftovers or cups of coffee, though. Microwaves are also used for radar, television, and satellites. Microwaves occur at higher frequencies, with billions or even trillions of cycles occurring per second. Since writing out 4 million hertz is kind of clunky, it would be written as 4 gigahertz or 4 GHz. Digital radio is broadcast at a frequency of 2.5 billion hertz per second, or 2.5 gigahertz. Infrared waves occur at an even higher frequency than microwaves. Infrared waves are used to power television remote controls and for thermal imaging, like when using a pair of night vision goggles. When you feel warmed by sunlight, the energy you feel is infrared radiation from the sun. Since infrared waves have such high frequencies, their wavelengths are so tiny they are only hundredths or thousandths of an inch. All electromagnetic waves are light, but the band of the electromagnetic spectrum that people and animals can see is called visible light. When a beam of light passes through a prism, a person can see each color of the rainbow separated into their individual wavelengths. Red, the longest of the wavelengths, measures around 700 nanometers. Yellow is around 600 nanometers, and violet, the shortest, is around 400 nanometers in length. The electromagnetic spectrum can be shown in a diagram broken down by frequency and size of wavelengths. The rainbow-colored section shows visible light. After visible light is now back to electromagnetic waves, which humans can no longer see. Ultraviolet waves, or UV waves, measure between 400 and 1 nanometers and occur at very high frequencies, often more than 1,000 trillion cycles per second. You might have heard of UVA and UVB waves since they are the type of waves sunblock protects against. There is a third type of UV waves, UVC, which are absorbed into the Earth's atmosphere. A little UV light is good for you though, since it provides your body with the ability to produce vitamin D. The next type of wave is the X-ray. If you have ever broken a bone or thought you might have broken a bone, you probably were given an X-ray. X-rays have such small wavelengths that scientists start to think about them as particles of energy called rays instead of waves. At 1 million trillion wavelengths per second, X-rays provide such strong bursts of energy they can kill cells in your body. Lastly, on the electromagnetic spectrum are the gamma rays. Gamma rays are powerful enough to break the bonds between molecules. They are the waves emitted into the air when the nuclear bombs explode. Gamma ray bursts, made by supernovas billions of light years away in space, are several times brighter than our sun. Waves are all around us. Electromagnetic waves do not need a medium to propagate through. Electric and magnetic fields both produce vibrations, and together they create electromagnetic waves. Electromagnetic waves are transverse waves, meaning they are measured by their amplitude and by their wavelength. In the late 1800s, Heinrich Hertz and Guglielmo Marconi conducted experiments with electricity that led to the discovery and use of radio waves. Today, the 7 types of waves are represented on the electromagnetic spectrum. The spectrum ranges from low-frequency radio waves to the strong and high-frequency gamma rays. In between the two are the other types of waves, including the familiar microwaves that are used to heat food and visible light that humans can see. Like gamma ray bursts, each band on the electromagnetic spectrum allows us to learn something new about the universe. For example, infrared waves show the heat from other planets, moons, and stars. The ultraviolet waves allow us to learn more about hot stars, and X-rays allow us to find gas clouds in space.